You're listening to Stanford Medcast, Stanford CME's podcast, where we bring you insights from the world's leading physicians and scientists. This podcast is available on Spotify, Apple Podcasts, Google, and Stitcher. If you're new here, consider subscribing to listen to more free episodes coming your way. I am your host, Dr. Ruth Adebuya. This episode is part of our Hot Topics mini-series, and today I will be chatting with Dr. Brandon Guenthart. Dr. Guenthart is a board-certified, fellowship-trained cardiothoracic surgeon. He is a clinical assistant professor in the Department of Cardiothoracic Surgery at Stanford Medicine. He earned his medical degree at Temple University School of Medicine, completed a general surgery residency at Cornell, and a postdoc research fellowship in tissue bioengineering in the Laboratory for Stem Cells and Tissue Engineering at Columbia University. He then completed a cardiothoracic surgery fellowship and advanced fellowship training in cardiothoracic transplantation and mechanical circulatory support at Stanford University. Dr. Guenthart has conducted research supported by grants from the National Institutes of Health, Stanford University School of Medicine, and Columbia University. Most recently, he was involved with developing a novel beating heart procedure to revolutionize the sphere of cardiology. Thank you so much for chatting with me today.
It's a pleasure to be here. Thank you.
I am really excited to chat with you today on all things heart transplantation. A great place for us to start will just be to jump into what common conditions or diseases may lead individuals to require heart transplantation.
It's really a range. Generally, these are patients that have some progressive form of heart failure. They're being managed and get referred to our center. Most commonly, it's some form of cardiomyopathy. So the non-ischemic or variety is more common, but certainly ischemic cardiomyopathy we see quite a bit. Valvular disease, other rare disorders or syndromes. And at Stanford specifically, we see a lot of congenital patients. These are patients that have gone through the system and had multiple prior surgeries, corrective surgeries during childhood, and have some altered physiology that ultimately fails and needs a transplant.
It sounds like when you're seeing patients, they're at their worst already when they're being considered for heart transplant. How are candidates identified and evaluated?
Probably two most common pathways. These are patients that are being managed by their primary care doctor or their cardiologist in the community. They have some known cardiac condition that is just slowly getting worse over time. And at certain thresholds, when they really fail medical therapy and are continuing to get worse, they get referred to our advanced heart failure center and our transplant team. That's the method and pathway that we prefer. This is a controlled setting. We have plenty of time to look at them and evaluate them. Unfortunately, a lot of patients come to Stanford and are incredibly sick. And these are patients in cardiogenic shock that end up on some form of mechanical support at some outside hospital, and they come to Stanford as a rescue. And we then do what's called an expedited transplant workup and really try to get them evaluated and see if we can transplant them or get them to some sort of destination therapy when they otherwise would have no chance at survival.
One of the things that surfaced as I was preparing for this conversation is there truly can be a shortage of healthy donated organs. You talk about heart transplantation, which is even more specialized. What are some challenges that you and clinicians like yourselves face when meeting the demand for heart transplants?
First, the most common issue is the shortage of donor organs. And that really limits our ability to offer this life-saving therapy to the most number of patients possible. So that, I think, is our biggest constraint. If it wasn't for that, we would be much more aggressive and be able to list patients sooner and offer transplant to more people. So just the shortage alone really constrains our ability to help people. And heart and lungs specifically are really affected by organ quality, what they can tolerate in terms of time outside the body. And so it really limits our ability in comparison to other organs like kidney or liver. But then in terms of just offering transplant, it's really that time crunch that really hurts us as well. Patients come to us incredibly sick, and there's a really narrow window to get people transplanted before they go into multi-organ failure and become outside of the transplant candidacy window. And so we want to get these patients in and evaluated, listed at the right time before they get too sick, because then once they get too sick, then they're not going to survive a huge operation and what it takes to get past a transplant surgery.
You mentioned a transplant window, are there general parameters around that, or is that unique to a patient?
The general philosophy holds for everybody, and you want to transplant them when they're in need. So you never want to take somebody and transplant them too early. And so as long as they're doing okay and thriving, you try to push them out and transplant later. But again, you want to transplant them before they get too sick. And so it's really striking that balance of optimizing the time the patient can go without a transplant. But as soon as they need it, we try to get it for them before they get too sick and then become outside the window. Once somebody's transplanted, another timer starts to tick. Once organs are transplanted, they also have a shelf life. And we're doing our best in terms of addressing different things clinically and in the lab and from a research perspective to make these organs last longer once transplanted. But that's really the balance we face is transplanting them right in that window so that they get the most amount of life before transplant and the most amount of life after transplant.
It sounds like a very challenging balance to navigate through. And then, even if you do navigate that, it's an incredibly complicated procedure. When we talk about these traditional heart transplant surgeries, what is the overall success rate for these types of surgeries?
We measure success individually as a center, nationally, with a lot of different metrics. The most common metric that if you look at transplant centers and pick your transplant center, 1 year mortality is generally accepted as a really a benchmark. In heart transplant, the national standard, 90% 1 year survival is where most centers are. Stanford is among a handful of centers that are well above that 90% mark and lead the nation. So we're very proud of that. At 5 years survival mark, most centers hit around 80%, and we're trying to do better and better. But we're really trying to get past just 1 and 5 year survival as a measure of success. We want our patients to live a decade or more, and we have many patients that are living decades after their transplant, and that's what we want for everybody. And also, we're looking at other metrics, not just are you alive or not? We want to know your quality of life and not just are you living, but how are you living? And is it a good quality? And are you happy after your transplant? So we're looking at all of those metrics in our program to continually improve and try to redefine what success is. But certainly success is leaving the hospital, being home with your family and living a good quality of life. And our goal is to make sure that's decades, not just years.
You alluded to this earlier where you said there are complications even post transplant. What are some of these risks and complications that are associated with this transplantation procedures?
Yeah, so this is going to go to another one of those narrow windows. So after transplant, once you leave the hospital, one of the hardest things to also get into that perfect window is immunosuppression. And so our patients are constantly being evaluated about their level of immunosuppression. We want their immunosuppression enough so that there's no issues with organ rejection, but too much immunosuppression that drives down your immune response predisposes you to infections and hospitalizations and other issues. Our transplant cardiologists are incredible, and they're the ones that are managing this as an outpatient, and our pharmacists as well, that are really focused on that issue and just really maintaining that immunosuppression and their drug regimen so that, again, we try not to have any issues with rejection and graft dysfunction, but we avoid all the other complications that go on the other spectrum of too much suppressions. Those are some of the complications we face long term just from the drug therapy. Grafts themselves, like I mentioned, they have a shelf life. And so the longer they're in the body, they ultimately decline in function. We have vasculopathies that happen. And so we have coronary artery calcification tends to progress faster in grafts than in native hearts. So that's something that affects function that many people are focused on in terms of how do we improve that. And a whole host of other issues that, again, come along with immunosuppression. And so these patients are just at constant risk for being affected from when we had the spike of the COVID pandemic. They were really at risk, and we had many patients hospitalized with COVID. Even once they got the vaccine, they don't mount the same response to vaccines. And so, again, they're still high risk. So basically, for life, transplant patients kind of battle with a lot of issues with complications.
I'm glad you brought up the COVID-19 pandemic because I was curious about what the implications for a transplant patient would be. I want to segue to some novel developments that you've been a part of. You have been involved in developments on beating heart transplants from cardiac death donors. Can you talk more about this procedure?
I'll first start by just a little background about the type of donors that we have now versus traditionally. Traditionally, all of our organ donors came from brain death donors. So these are patients that had some sort of devastating injury that led them to be legally declared brain death, and those were the major source of organs from our donors. More recently, we are now able to get organs from cardiac death donors. So these are patients that have some sort of devastating injury, medical illness that they're not going to survive from, but they're not legally declared brain dead. And these patients have to have withdrawal of care and they have to expire. And then we're able to procure organs and then we place them on machine perfusion. And those machines allow us to not only support the organs, but then allow us a period where we can evaluate them to see, are they healthy enough to transplant? And before we had this technology in machine perfusion, we just couldn't use those organs because it was too risky, not knowing if they would work once transplanted. Now we have that, and the DCD pool has completely expanded. And so it's a new avenue for more organs and to address that shortage issue that we had talked about. That's great. We love the DCD pool. It's been a huge advance in our field. The issue with using those donors and using machine perfusion is hearts, in order to go on the machine, have to be on ice and arrested, and then they get rewarmed and we evaluate them, and then they start to beat and they're on the machine being perfused. But in order to transplant them, we have to arrest them again, put them back on ice and sew them in. And so those hearts go through 2 periods of cooling, rewarming, and they get predisposed to multiple hits of ischemia reperfusion injury. That really affects the initial function of the heart. They don't like those multiple periods of cooling and rewarming. And although it's great that we get those hearts, those patients tend to suffer a little bit more in terms of needing more support, being in the ICU longer. And what we don't know is, does that affect long-term outcomes? Dr. Wu and others in the department really pioneered this idea of, do we have to really arrest the heart again, or can we transplant the heart beating and just keep it warm and perfused and eliminate that second period of ischemia reperfusion? And so now our whole group, we take the heart on a box on the machine perfusion, and instead of putting it back on ice and arresting it, we've designed a system where that heart gets perfused. We bring it over to the patient, and we've really modified techniques and changed our practice so that instead of sewing the heart in when it's arrested and on ice, we sew it in while it's still warm and beating. And so that's eliminated that second period of ischemia reperfusion. It really changed the way that DCD heart transplant is performed, and we've been very happy with our initial success.
In terms of the time for the actual surgical procedure, do you spend more time with a beating heart?
Initially sewing in the heart, we may spend longer to sew it in. Part of that is technically it's a little bit harder, but the other part is we don't need to rush because the heart is warm, beating, it's getting blood supply. When a heart is cold on ice and we're sewing it in the body, that's called a warm ischemic period, and it's very damaging to the heart. And so we're very focused on sewing that heart in quickly. But in our method, there's no rush. The heart is already beating, it's warm and perfused, and so we can take our time and do a good job. Sewing it in may take a little longer, but what we find is those hearts function immediately better. And so we are staying less time in the operating room on bypass, and those patients are able to wean off support quicker.
That is incredible. What an amazing innovation. We know that innovations in medical procedures is not easy, and it often involves challenging established norms and procedures. What challenges did the team face in proposing the development and implementation of this process?
It's a great question. I agree that challenging the status quo is always hard in medicine. We're lucky a little bit in the realm of transplant surgery in the fact that our field is relatively new. There's constant innovation happening all around us. This is a field that's really dealing with the sickest patients and offering a life-saving therapy, and we're trying to expand that. And so the field overall is very accepting of change, innovation. And when we propose this, I'd say that it's not as shocking to the group and community as maybe it sounds. That's number one. I think we're lucky in our field. Two, anytime you think about changing and challenging status quo, it really has to be rooted in sound medical background and have good rationale to do it. For as much as you can, I think it's really important that it's supported by as much research, whether it's basic science in the lab, large animal models, anything that you can to support taking something to the bedside before it's implemented. And then lastly, the most important thing is when you do something new, that it's very transparent and open, and that others around you know what you're doing. that it's well reported. And for instance, we published now 3 papers on our technique and really shown other groups how to do this. And it's actually already been implemented at other centers. We just had our series of early clinical outcomes from our initial series of beating heart transplants that's coming out in JAMA. And so we wanted to publish our results. We've now spoken at multiple conferences and have several coming up where we're showing videos and talking the procedure through, listening to feedback from other leaders around the world, and really showing what this technique has to offer and getting everybody's opinion and buy-in. So I think those are the keys when you're trying to innovate and bring something new to a field.
It sounds like it is fertile ground for new ideas, new technologies, and new procedures. That's really encouraging to hear because it sounds like the patient population does require clinicians to be innovative. You talked about the fact that you were happy with the results, and I know that you have publications coming out. Can you provide some insights into some of the positive patient outcomes that have come from this beating heart procedure compared to your traditional heart transplant procedure?
Of course, this is our early experience. So these are early outcomes. And what we're looking at is 30 and 60-day outcomes. And the key markers for us are ICU length of stay, use of mechanical support like balloon pumps and ECMO, use of inotropes, and how long, instances of needing for dialysis and renal failure after transplant, and of course, early survival. So these are all the things that we're looking at for those first 30 or 60 days. And fortunately, so far, what we've really found is that by eliminating that second period of arrest and ischemia reperfusion, number one, in the operating room, we're able to wean off bypass and get that patient out of the operating room sooner. We've had no instances of these patients needing balloon pumps or ECMO. And on average, they stay a little bit shorter in the ICU, a little bit shorter on the ventilator, less inotropes. And so far, on those specific markers that we're looking for, just signs of early outcomes, we're very happy. Of course, as we're in the beginning stages of this, what we don't know and what we're looking forward to finding out is, will this technique lead to better long-term outcomes? So will these grafts function better for longer, and will patients survive longer? And we're very interested in that from a basic science standpoint, as we really think that a lot of the later term rejection and issues with graft failure are really related to that ischemia reperfusion period. And so we're hopeful that by eliminating one of those periods and decreasing the injury to the graft, that we'll see long-term benefit. Time will tell, and we'll watch these patients very closely.
That's very exciting, and really looking forward to what long-term outcomes come out of your work. As we wrap up, I was wondering if you could share some of the next steps that the team has around the beating heart transplant procedure. And specifically, I'm curious how you envision this technique evolving in the coming years.
From a technical standpoint, we're continuing to make slight adjustments in our technique, and that's why we've had 3 papers out, because already in our short experience, we've found ways to make it a little simpler, make it a little streamlined, and really help others do this. As you can imagine, technically, sewing a heart that's beating and moving is a little bit more difficult and takes a little bit more thought and strategy versus a heart that's just arrested on ice that people have been doing for decades. This is something that's translatable, that multiple surgeons have taken up and can perform successfully. In my lab, in a large animal model, we have residents that are in the beginning stages of their learning, able to perform beating heart transplant in a large animal model. This is something that is translatable to other centers. Other things that we're looking forward to in the future and we're looking at in the lab is we've, of course, clinically transplanted these hearts beating on the second phase, from the device to the patient. But we're really focused on, can we do this from start to finish? And so can we procure hearts beating, keep them on the machine beating, and then implant beating, and really change the way that heart transplants are performed around the world and do total beating heart transplants? So that's something that we're already pursuing and working on techniques for in large animals. We're looking at, with this technique, it's really the first model ever to investigate ischemia reperfusion. And so we're able to perform heart transplants with no ischemia reperfusion. And how does that compare to either one period of ischemia reperfusion or 2? It's an incredible research model to pursue. There's a lot of things that may change in heart transplant just based on this one innovation. And I think we're getting really good feedback from other centers that have already tried and are looking at this as a potential way to improve heart function after transplant and ultimately allow these patients to live longer and healthier.
Thank you so much for sharing a little bit more about this innovative procedure, and really excited to keep an eye out and ear out for some more of the outcomes that come from this space and encourage everyone to take a look. Thank you so much for chatting with me today.
It's been a pleasure. Thank you so much for highlighting the work and for everything you do to really help spread the word about heart transplant.
This episode was brought to you by Stanford CME. To claim CME for listening to this episode, click on the Claim CME link below or visit medcast.stanford.edu. Check back for new episodes by subscribing to Stanford Medcast wherever you listen to podcasts.